Okay, class 4.5, graph using slope-intercept form. So we're continuing, every section builds on the next section. So you have to make sure that you're understanding the previous section, because you can see it takes the last section and it builds a little bit on that. So slope-intercept form is again something that you should have seen. Okay, and here is slope-intercept form. Y equals mx plus b. So m is the slope, and that was said very early on in this chapter. And then b here is the y-intercept. So we have already graphed x and y-intercept. And the y-intercept is the point here that crosses through the y-axis. So in a line, you have to have two parts to put it in the slope-intercept form. You have to know the slope, m, and you have to know the y-intercept. So right here, we can look at this and we can tell that the y-intercept, the b part, is 1. So we can fill that part in with 1. Then the slope, you should be able to see it's going upward, so it's going to be a positive slope, and we've read in the last section how to look at a graph and tell the slope. You look at the ordered pairs, one is here and the other one is here. So you count rise over run. It goes up 1 and over 1, 2, 3. So the slope is the change in y, which is 1, over the change in x, which is 3. So now I know the slope is 1/3. So I can write an equation, y equals 1/3 times x plus 1. So that is slope-intercept form. So we're going to go ahead and we're going to practice writing a few of these. Before we start, we have one already in slope-intercept form. So you can see that it's in slope-intercept form because it looks exactly like this. Okay? You've got the number before the x here. Tells me that this is the slope right here. Then this matches up with here. This is the b. So this is going to be the slope and the y-intercept. So it wants us to identify the slope and the y-intercept. So this first one's real easy. So the slope, which I'm going to say m, that's what they said, the slope is 5. And the y-intercept you can say is -3, or you can write it as an ordered pair. Let me go ahead and move that a little bit. We could write it as 0, -3. Either way, you can see that. You can go ahead and do it like that. Alright, so there's one that's already in slope-intercept form. But let's go ahead and write one that's in standard form. So it looks like this. 3x minus 2y equals 12. Actually, let me change this. It's 3x minus 3y. Alright, so it is not in slope-intercept form. Slope-intercept form means it has to be solved for what variable? We can see right here, has to be solved for y. So this equation is not solved for y, so it's not in slope-intercept form. So I'm going to go ahead, and this is where solving for equations is something that you have to be proficient in. So we're going to go ahead and we're going to solve for y. So we don't need the 3x. We've got a plus 3x. We're going to subtract it and bring it to this side. This is going to cancel. Now be careful. Bring down the negative. Okay, don't forget the sign. So it's -3y equals -3x plus 12. Remember, you always want to write the number with the x first, because that's how it's going to match the slope-intercept form. Then it's still not solved for y because we've got a -3. So we need to divide by -3. That means I divide the first part, the slope, and the y-intercept by -3. So -3 divided by -3, anything divided by itself is just 1. We don't write the 1 in front of it. It's understood to be 1y. And here's where you have to be careful with signs. Negative 3 divided by negative 3 is going to be a positive 1x. We don't have to write the 1 in front. And then positive 12 divided by negative 3 is going to be negative 4. Okay, so now I've solved it into slope-intercept form. So that's the first thing. But then we have to answer the question. It wants the slope and it wants the y-intercept. So here, the slope is going to be, what am I going to put? What number is considered in front of here? It's going to be a 1. So the slope is a positive 1. The y-intercept is negative 4. Okay. We put a little equal sign, negative 4. We can write it as an ordered pair, 0, negative 4, however you want to do it. All right. Let's do one more just to be on the safe side. So I'm going to move this down a little bit. Camera down. Let's go ahead and do this one. X plus 4y equals 6. So remember, we always want it to look like this. Okay, so it doesn't. So basically you are looking to solve it for y. So I got to get rid of this x, so plus x, so I subtract x and bring it over to this side. Cancel this. I now have, it's a positive 4y, because it's positive I don't need to write that, that's understood. The one before it was a negative, so you had to bring down the negative. So 4y equals, I don't say 6 minus x because I want it to look like this. I say negative x plus 6, okay? Always the number with the x. Now I need to divide by 4 because to get y by itself I have to divide the 4. So I divide both parts by 4. It now becomes y equals negative x over 4. You read it like that, but that is the same as saying negative 1/4 times x, okay? Because this is understood to be a negative 1. So both of those mean the same. You can see it as negative x over 4 or negative 1/4 times x. They mean exactly the same, and you have to get used to seeing in algebra different ways meaning the same thing. Plus the b is 6 over 4, and we don't leave it as 6 over 4 because it can simplify. We can divide it by 2, so it would be 3 over 2. So here you can see that we don't have a nice integer, we have a fraction for both, and that's fine. So the slope is negative 1/4. It's the number in front of x. It is not x. Slope is the number in front of x. You never put the x with it. The y-intercept, which is b, is 3 over 2. If you wanted to write it as an ordered pair, you can say 0, 3 over 2. Okay, either way, it's fine. So that takes care of figuring out what the slope and the y-intercept is. The next example is going ahead and graphing. So we're going to solve it. So I'm going to pick another piece of paper up here, another board. We're actually going to solve it and graph it. So let me move that. Okay, so here we go. So they want us to solve and graph this. So it just says graph the equation. The reason we need to solve it is because it's not in slope-intercept form. And to graph it, we need it in slope-intercept form. Remember, when it looks like this is standard form. So let's just solve it for y. This one's not too difficult. Subtract 2x, subtract 2x. That's going to cross out. So y equals negative 2x plus 3. So there it is in slope-intercept form. So we know that the slope is negative 2, and we know, sorry, let me put this over. We know that the y-intercept is 3. Okay? So we can see those things clearly. So we're going to go ahead and we're going to use those 2 points to graph, or 1 point. We know that the y-intercept is 0, 3. All right, so let me just quickly do a graph here. Doesn't have to be anything special. just so that you have a rough idea. So looking at this line so that you start to have a clue, because that's what math is remembering the previous information and kind of looking at it, and you have an idea if you're doing it correct or not. So the slope is going to be negative, so I should expect a line going down. All right, so you should be aware of those things. So if your line is going up or it's not going down, you should look at it and say, okay, something's not right here. So let me mark off by increments of 1. I'm just going to say 1, 2, 3, 4, 5. I'm going to put 6 here. That'll be enough to graph this. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so it starts at 0, 3. 1, 2, 3. So here I wish I had a different color. I'm just going to kind of make it a big dot. 0, 3 right here on the y-intercept, okay? And the slope is negative 2. So that means negative 2 is on the change in y. So what is understood to be the change in x? What is under a number? If I just say 3 or 5, what is it over? We don't write it, but you can still write it as a fraction. It's always over 1. I hope you realize that. When you say 5, you're saying 5 over 1, okay? We just don't write the 1 because we know that there is a 1. So that means that from here, every time I go down 2, because we're going down 2, we go over 1. So there we go. My line is pretty steep. It looks like this. This is a very quick graph. It went through 0, 3. So here's 0, 3, and then I went down 2 and over 1, and here's the other point right here. Okay, so you can see that you have the line going down. So you can see it matches. It's a negative line going down. Everything looks good. So that's how you take an equation in standard form. You solve it into slope-intercept form. You use the y-intercept to start. So we know that point's at 0, 3, and then you use the fact that you know how to do the slope. You know the slope is negative 2. So it's negative 2 over 1. So down 2 and then over to the right 1, and that's your next point. If I wanted to do the next one, I'd go down 2 and over 1. And so you can keep doing points. We only need 2 for a line, so that's fine. All right, so that's that example. The next one we're going to do is we're going to use this here to look and see change of slopes of a line. Okay, so make sure that we can see it real good. Okay, let me see. Okay, good. Don't want to make it too bright. Okay, there we can see it a little bit better. All right, so let's look at this. We've got an escalator. To get from one floor to another at a library, you can take either the stairs or the escalator. So you can walk up the stairs or you can ride the escalator. You can climb stairs at a rate of 1.75, which is the same as 1 3/4 feet per second. So every second you're going to go up almost to 1 3/4. But the escalator rises at a rate of 2 feet per second. So you can see it's 1/4 of an inch faster. So every second you go up 2 feet. So you're going to go faster on the escalator than you are walking. You have to travel a vertical distance of 28 feet. So you're going up 28 feet. The equation models the vertical distance, d in feet, you have left to travel after t seconds. So on the stairs, the equation is d equals negative 1.75 times t plus 28. Because remember, when you're looking at the graph, you're starting at 28 and you're going down negative 1.75. So they're saying from the top going down here. So the escalator, we know it's negative 2 because it takes 2 seconds to go up or go down, and again you're starting at a height of 28. That's what they've told you. So you look and you would start at the same here at 28. I'm using the pointer right here. Okay, and they both start at the same height, But then you're going to go ahead and you're going to graph the first one. So it's negative 1.75. So every time you go down 1, you go over 1 3/4. And you're going to plot that point all the way down till you get to the bottom. Okay? Then the other equation, you're going to do negative 2t plus 28. So when you do that, you're going to keep going down. So the one that's negative 2 is going to be at 14, and the one that's negative 1.75, they start out the same, but eventually those goes down to 16. So how much time do you save by taking the elevator? You look here, one's 14 and one's 16. At the end it's going to tell you the time, because along here is the time. This way was the height. We started the height of 28. So you can see one gets there at 14, one gets there at 16. The faster one obviously is the elevator. It takes 14 seconds. The longer way is you walking 16. So the difference is 2 seconds. You save 2 seconds of time by doing the escalator. Okay? And a lot of times you're having nice graphing paper, you graph it out, then you can look and you can see the answer. Okay? Example 4 is a word problem, so I'm going to go ahead and use this so we can look at the graph and we can read through it and see what it's saying. Okay, so it says change of intercepts of lines. So they're using a word problem, but it's using the intercepts of lines. Okay, sorry, I moved around, it made it kind of dark. So a company produced 2 30-second commercials. One was for $300,000 and the second was for $400,000. Each airing of either commercial on a particular station cost $150,000. Okay, the cost C in thousands of dollars to produce the first commercial and air it n times is being given, because they have to tell you C's the cost, so they told you. So C's like the Y is 150 times n is the air time, plus 300. Okay, and then the other one, the cost to produce the second air time is 150 n plus 400. They said 400, but they're doing it in thousands. So one you can see is 300,000 and the other one's 400,000. So you can see that from the commercial. Okay, the 300,000 and the 400,000, they just say 300 and 400, because then when they do the graph, they put the cost and they say it's thousands of dollars. So that's 200, but it really means 200,000, 400,000, 600,000. It's just an easier way to write the graph rather than writing all, 400,000. That takes up a lot of room. So you can do it by that and say it's in thousands. So along here is how many times it airs. 0, 2, got 1, 2, 3, 4, 5, 6. Okay, so we graph them. And it says graph both equations on the same coordinate plane. That means together on the same in the first quadrant. Don't graph them on separate piece of paper. So when we graph the first one, it starts at 400,000. So here it's going to start, and it's 150. So the slope is 150. So you would go up 150 over 1 and go here and keep graphing until you get all these points. Okay. The second one starts at 300,000. It also has a slope of 150. That means you go up 150 for every one. And if you notice, when you look at these lines, what do you see? You always have to check. Don't they kind of look parallel just looking at them? But the way that you tell is you look here at the differences between here. From here to here is 100,000. Then from here to here you can see another 100,000. There's certain parts where you can definitely tell where they're both right here. But also the big thing that will let you know if something is a parallel line is by the slope. Look at this linear function. It has 150 n plus 300 This has 150n plus 400. The number in front of the variable is the slope, or the rate of change. So you can notice on the first line and the second line, they both have 150. That means the slope or the rate of change is the same. If the rate of change or the slope is ever the same in two lines, they're parallel lines. So you're learning something that will help you. So it says two lines in the same plane are parallel if they do not intersect. So parallel lines never intersect. They use them on roadways. They use them on railroad tracks. You see parallel lines everywhere. Windows, anywhere where you don't want things to intersect and keep the same distance, okay? Even on the TV, it's parallel lines along the top, along the sides. Okay, so because the slope gives the rate at which a line rises or falls, two non-vertical lines with the same slope are parallel, just like I said. So that's a biggie in algebra. You're going to come back to that. So if the slope is the same, they're parallel lines. Okay, the last example we have is to identify parallel lines. So here I've drawn three lines, okay? So the first one is A, the second one is B, and the third one is C. Now you cannot just guess. Even though you might have an idea what you think is parallel, you have to verify it by either you were told in the previous problem that the slopes were the same, so you didn't have to guess, or you have to figure it out. So here, I don't know what the slope is, but I have two ordered pairs. So what I'm going to do, and I can see all these lines are positive, I'm going to have to get the slopes on the three lines, and if any of the two are the same, they're parallel. If none of them are the same, they're not parallel. So let's use our rise over run. So we know up 1 and over 1, 2, 3. So the slope of A is 1 over 3. So 1/3, rise of 1 and over 3 to this point. The second one is up 1, and actually it's up 2, and then over 1, 2, 3, 4, 5. So the second slope is 2/5. Okay, so they are definitely not parallel because they're not the same. So let's look at the third line and see if it's any of these, if we can see if it's parallel. So here we go up 1, 2, and then over 1, 2, 3, 4, 5, 6. So C is 2 over 6, but we don't leave it as 2 over 6. It reduces to 1 over 3. So I can see that A and C have the same slope. I have to prove that they have the same slope. So I either have to count it, or I have to be told it in the other problem. You can't just guess it. You have to verify that they are parallel. So A and C are parallel lines. That's the figure for parallel lines. Okay, we are done with 4.5. Great job.